It's going.
All right, here we are. This one is for you, Shannon and Joel. Shannon will be back in from taking a test. Joel, where are you? I hope you're doing okay. So watch this and catch up with us.
Virus got your neck.
Here we are, chapter 11. Wow, 11 out of 12. So again, I'm going to give you the meat, maybe the meat and potatoes, but no side dishes beyond that, no crumbs. So I'm going to give you the main part so that we can quickly move to preparing for studying for the AP test and the final. So here we go. Up till now, you have seen a Z statistic, and what other statistic? All right, Z statistics, T statistics. And they become very, very boring, so we're going to learn a new one, and it is chi-squared. This, I don't know how to write a chi in Greek, but when you look in the book, you'll see a chi. It's like a fancy X with a long leg. So chi-squared is read, chi-squared.
Miss Powell, do we have day notes?
Yeah, I'm coming with it. Chi-squared statistic. All right, so even before you get your notes, I just want to introduce you to what we're doing here. So, here it is. We're going to learn about a chi-squared statistic. This whole chapter is dedicated to it.
I hung this.
I'm going to lay
You see what I was
it
doing?
here.
I was like reading like I said that's probably really annoying for the video, like the audio.
I thought you were doing that on purpose.
No,
I didn't even think about it.
Okay, there we go. So,
Thank you.
It's like when play a song on the world's smallest violin.
alright, so we're going to learn about a chi-squared statistic. It turns out that all the statistics that we've looked at so far have been quantitative. So like the difference of two proportions are numbers that are subtracted. The means are also quantitative. So we're going to take a step on the wild side and look at categorical data. So your first note is the chi-squared statistic deals with categorical data. So all the chi-squared values are going to be tests. So we're going to look at tests only. So we're going to look at chi-squared tests, not intervals. So we don't have to memorize so much. As we did with the difference in proportions and means, we had to know p-land, we had to know interval land, and we had to know tests. We're only doing chi-squared tests. So we're going to perform a test to see if the hypothesis, the hypothesized distribution, is valid. So that will make no sense. It's not even worth writing down until we actually do one. So let's look at a distribution of categorical data and see how it differs for two or more populations. So we're going to do a chi-squared test. So we're going to jump right in and do one instead of talking about it. We're just going to actually do it. So again, our data is categorical now. And the first thing that I've started there for you as a chart are what's the Mars company claims there. The percentage of plain M&Ms are. So they say, did I write this on your graph, 13% brown, etc.? So Maggie, read the rest.
13% red, 14% yellow, 16% green, 20% orange, 24% blue.
All right, this is what Mars distribution candy company says that they put in their M&M bags. So the question
M&M's is Mars?
Is there enough? We're going to let's go ahead and make our first chi-squared. Here's our first claim, our null hypothesis. Remember, chi-squared is going to be test, so we're going to make a claim about this distribution. And H sub O is our first example, so put it somewhere on your notes there on the front. And the null hypothesis for your chi-squared test are going to be similar to this one. The company's stated color distribution is correct. The company's stated.
We have to write words for our hypothesis?
I'm sorry?
We have to write words for our hypothesis?
It is true. The company's stated color distribution is correct. And another, if you're uncomfortable with that, like Dan is, you could write it like this, so I'll put it up there. Or H sub O could look like this. It could say, you could actually make a list. So you could say it such as the proportion blue equals 0.24. The proportion orange, read them to me again, Maggie.
0.2.
Proportion, what's next?
Green.
Green.
0.16.
Keep going.
Yellow. 0.14.
All right, yellow. And
Red is 0.13.
and
Brown is 0.13.
all right. So you could write them all out. You do not have to. So that is a list of them. Notice the P's do not have hats. So this is looking at proportions from the whole population. The claim is that the proportion of all the blues made by the Mars Candy Company is 24%, and so on. So this is another way that you can list your null hypothesis. Or you can just say of the words as I stated. So if I was using words, what do you think the alternative hypothesis might be? Kevin, what do you think could possibly be?
The company is wrong.
Right. The company's stated
The company statement. You fail to accept.
color distribution is not correct or is incorrect. I guess is the correct way. Is that the correct way to say not correct?
Yeah.
All right, incorrect. All right, so I don't know how I would write that with the symbols, because if I wrote what this means is, and the alternative hypothesis, if any one or more of these are wrong, then we can say this. So is there a way to write that with these symbols?
I would
That's
just
gonna
say,
take forever. You'd have to write.
I would just say like HA colon
You keep going, explain it.
dist equals
All right,
check
so
mark.
this does not equal this?
No, write HA colon DIST for distribution equals check mark.
Miss
Okay.
Powell, can I come up for a second?
Yeah, go
You
ahead.
have to do it so, like, one of these would be wrong, so you'd have to write all of them and do this, then write all of them
Oh,
again,
yeah, but
and
what
have that
if
be
two of
correct
them
and do
were
this
wrong
one.
and one of them? And
Oh,
Then you have to know specifically. Because you're either saying they're all correct or
You have to
they're
list
not
out
all
of them.
Or
correct.
Mr.
Yeah.
Paul, just
You
list
have to
all of
list out
them
every
and put an or in
Yeah, you'd have to list out all.
Just
all
do
combinations.
blue
But it could be
design
and.
0.24
Hey, I'm
or
just saying.
Yeah, that might
Yeah,
be
she
right.
has
That's a good way.
Or you could just
Alright.
write
Actually, saying
H
this
sub
doesn't work
A
for my
does
brain.
not equal H sub O.
If that makes sense.
Oh,
I mean, it's the same as these
yeah,
words. The
But you can't do it
company's
for HF.
So
You can only do it
the
for
whole
HF.
thing is,
Oh,
the
distribution
company's
is
stated color distribution is correct
Or
or
we could
it's
say-
incorrect. If any one of these is wrong, then we're going to go with H sub A. If any two of them are wrong, we're going to go with
We'll
H
keep it
sub
the
A.
formula.
So,
yeah.
you lose something?
That's fine. I just dropped it.
Yeah, Miss
There we
Powell.
go.
Like
That made sense to my brain.
you could either say does not equal check or equals X.
Okay. All right. To make it on my test or to make it on the AP test, I'm looking for this kind of a statement. All right. So, in order to decide whether we accept or fail to, we never accept, but in order to reject or fail to reject H sub O, we're going to have to compare our new statistic to the alpha value. So let me teach you about our new statistic.
I kind of wrote the answer to this one up here. Is that okay?
Daniel.
So So this is
For SLC, Brie and I are going to be late.
based on it, do you think
We're for the Thomas Chamber, like we're doing
All right.
kids ice cream, but it's perfect because I totally forgot about SLC today and had the chicken pot pie at 6.5 months.
That's fine.
Oh my
Did you have
gosh.
any sort of
6.5.
That's
It's a Davy window.
incredible?
is it like
I
a
was going to give them a push and I said, just go with
not
your
that
gut.
big.
My gut does not know.
Well, it's been kind of like
Kevin, what were you gonna say?
You went like this.
Okay.
Um,
Anything else?
I felt like I had more questions.
All right, well, look over it, take your time. All right, so we are going to find the chi-squared statistic and compare it to alpha, and we'll proceed as we normally did. If our statistic, we're going to take our chi-squared statistic and go to the p-value for it, and then compare to alpha. So that's not going to change. The question is, where do we go to find the chi-square statistic and where do we go to find the p-value from it? So that's what I'm going to teach right now.
Table C.
The chi-squared, you've been reading ahead.
No, I just want another table.
All right, here we go.
When I read this with the words,
Before we go to
I read
table
it as,
C,
ha,
as
the company
Maddie,
stated the color distribution is
foresaw,
incorrect.
let me show you what a chi-squared statistic looks like. It turns out chi-squared changes according to the degrees of freedom, just like our t statistic did. So the first one, and I've already drawn this on your paper, if the degrees of freedom is 1, it looks like that. Is that a skewed or symmetrical?
That is skewed. That's a
Very
whole
skewed. Very skewed.
Wait.
All right, so that's the degrees of freedom equals 1, and this is called a chi-squared distribution.
You're kidding me. I'm blind.
So notice, like before, when we had the z statistic, we had the normal curve. The chi-squared curve does not look normal at all. It's skewed. What about for degrees of freedom equals 4? Is it still skewed?
Yes.
Yep.
Yes.
All right, so degrees of freedom equals 4 is still skewed. Is it? Then what happens when degrees of freedom is 8? Skewed?
Less? Not
but-
quite as
It
skewed.
is slightly skewed. All right. So if you might make a note there's several things I want you to note about the chi-square distribution.
I have a question.
As degrees of freedom rise, it becomes less skewed, but every graph is skewed. So it never is a normal curve, but it'll become less skewed as degrees of freedom increases.
Will it ever go the other way?
Sure.
So it doesn't ever
Did you
get
find it?
skewed. It's something
Yeah.
that's skewed.
Did you find it?
Yes.
Okay.
So
Every graph is
First time, like,
that looks like that one.
I mean as the so when DF gets larger, it goes like this.
Because this is saying
I'm just wondering if
the
it gets to a certain number, does it
in
like?
between here, and that is just a tiny
And
part of it.
I said that in here. I said within.
But I asked
even though
him.
it's only a little, like it's
Yeah.
still there.
Right.
Okay.
All right. I'll take
And
that
then,
as long as you
did you
defended it.
need this to be more wordy?
Strongest
Or is that-
For normal.
Yeah.
Yeah.
I've heard
That's fine.
of
That's
I
fine.
popped up Kaiba
Okay.
crystals.
So then I think
Cool. All right.
Is that not the right answer for 1?
What happened on number 1? Because
Every question
I
on the
got
test.
it
But
wrong.
that's what you must say.
As I
It's the
gave,
AP test.
I gave everyone credit for it, and it was the matched T or matched.
You got it right?
pairs. So if no, you wrote 2 samples. That's what I got.
You said you're
I
gonna
agree
do
with you, but
okay.
all right. So anyone who got it right, Morgan sat me down and tried to explain it to me, but it's still
Yeah.
not in there.
I also wasn't here for the lesson on matched pairs, so I could just not understand matched pairs very well.
Okay.
But, you know,
So,
those are fine.
as degrees of freedom increases, the chi-square distribution becomes less
The
skewed
mental calculus.
to the right. It's all skewed to the right, becomes less skewed to the right. Is that all I said?
Yep.
All
Oh,
right.
less skewed to the right?
Yeah, it
You
is
didn't say
skewed.
that.
It's always skewed to the right.
Yeah, because it goes down.
Because slope is, you would ski to the
Skiing
right.
to the
You
right.
ski to the right.
Yeah.
Because it's.
You
But
always
it's
ski to
always
the
that
right. You want to
direction.
ski down the right.
Right.
But every single graph is skewed?
Yes.
Every one.
It'll become less and less though.
But no exceptions, they're all
Right,
skewed.
it'll just approach it, sort of like calculus.
The one.
All right,
Oh, okay.
interesting. I have a
Wish I never
couple
would've taken
interesting
that
notes that I won't ask you about, but the AP test might, so we'll make a note of them. The mean of the graph.
These are just little AP notes.
Yeah, the mean of the graph. So if it was this one, the mean, remember, is pulled toward the tail.
make a mean
So the skewed graph, say on our degree 4 that this is the mean, I don't know, I'm just guessing. And then the mean of this one, since it's less skewed, it'd be more toward the top of the hill. So maybe here's the top of the hill, so maybe like here. Alright, so say those are the mean. The mean of the graph, and that's a chi-square distribution graph, the mean of the graph equals the degrees of freedom, which is quite shocking.
You go to eat it.
So the
Surprised
degrees
there's
of
ending.
freedom on this graph
Eats you.
was 4, so that's going to be the mean of that graph. So this
That's
is going to
nice.
have like 0, 1, 2, 3, 4, just like our Z graph and our T graph.
told me.
So the mean of this one is
Heart of
4,
darkness.
and the mean of this one, what we say, is 8. So I didn't graph it very symmetrically, but it's true. So it's just a little point that might come up. It will not be on my test. All right, if for degrees of freedom, here's another little note. This only is true for degrees of freedom greater than 2. So it does not work for 2 or 1. For degrees of freedom greater than 2, the peak, and what's the other word for the peak? Mean, median, or mode, the peak or the mode.
Is this another AP note?
Yeah, it's just a side note. The mode is at degree of freedom minus 2. So the mode is the highest part. So at the highest here, degree of freedom was 4. So the mode occurs at 4 minus 2. Just a little note. And that's all I want to say as side notes.
What do you do with less than 2?
It doesn't work. I don't know how you find the mode.
Yeah, is
Our
that
little
negative
formula is not the way.
two? Degree of freedom.
Wait, should be, is it less than 2 or greater than 2?
When degrees of freedom are greater than 2,
Okay.
then the peak is found at whatever the degree of freedom is minus 2. Alright, and last little note, which is not an unimportant note, and Maddie already mentioned it, we're going to use table C. So let me get you one of those. Table C.
Charity
I
C.
think that's all the tables, right?
Yeah,
Cardi B's
Have we
pregnant.
seen them all now?
Yeah.
Yeah, she is. Wait, I thought there was a table.
Gonna have a little lowercase b.
Oh, Cardi B.
A little lowercase b.
No,
Where
Ryan
is the
said,
table?
Ryan said a card.
No, it's right here. It is.
Yeah.
We already had that. Yeah, it's all.
Let's hope she doesn't
She
have a
had a
party
baby
C.
bump for a while, and then everyone was like, "Are you pregnant?" She was like, "I don't know." And then the other day, she was like,
I don't know.
Here's to hoping that she doesn't have to have a Cardi C section.
Here they are.
And like Chloe
Alright.
Kardashian boiling
Table
jazz or
C.
something.
That little baby's
I was looking at her sister's Instagram and she was like
We've done all the
like,
tables now.
saying how happy she was that Cardi was
So
pregnant.
we
At
are
the end,
so
she went
excited.
like
Maddie, that's
she
so good.
spelled out the word like.
Wait, what?
But
Alright,
I
can you
That's
show
the last
him table C?
Oh, I was like, I have it too.
Go. Can you instruct me on how
I'll just kind of.
to travel around?
So like, it says table C, chi-squared distribution values. You're going to be handed this probably. Doesn't have a back. The left column is DF as usual. Then we got some decimals at the top.
Two notes on the side.
Really good.
Oh, important note. Probability is above the line, not below. We will not do a 1 minus. Okay, we got it.
T is on B, Z is on A, and now chi-squared is on C. Alright, let us go ahead then and do one. I guess we should, I wonder if we should take the time. Let's grab a bag of M&Ms and actually do a chi-squared test on it to see if the companies, these are true Mars claims. So we're actually testing to see if H sub O, if we should reject it or fail to reject it. So let me get some M&Ms.
I'm confused. No, it's
I have a
Hershey
question.
brand.
Is the strongest metal in the world?
M&M's aren't Hershey.
Yeah, they are. No.
Yes, they are.
They're not.
They're
They're not Hershey.
Have you ever seen an M&M?
They're not Hershey.
I thought I had.
I remember. No, I remember because like.
Yeah, they sell them in the Hershey Park world.
Really?
Wait, does Hershey own Mars? Or like Mars
Oh,
is
yeah,
Hershey?
maybe Hershey.
All right, listen.
Those little, like, plush things.
I was gonna say they don't
Yeah.
have one for M&Ms.
Yeah, they do.
Yeah, no, they don't. They don't.
Yes,
They
Twizzlers.
don't. No, they definitely can't.
Oh, you're right. They don't.
Listen, Kit Kat Jolly
And they
Rancher.
have to.
No, they don't.
Kit
Kat Jolly
don't
Rancher
have it in
Reese's.
the bar.
Unless Hershey
And
owns
Hershey
Mars,
Kiss.
I'm sure.
No, they don't. They don't sell them in the
I just
shop.
feel like I've
Okay.
eaten M&M's at Hershey Park before.
Haley, can you grab a bunch of
I like
paper
bought
towels
them.
around
I didn't
working
like
on
bring
these
M&M's
stinky
to Hershey
tables?
Park.
Yeah. You two start counting.
Yes. Yeah, Hershey has their own fake M&Ms.
You two start
Hershey has
counting.
Whoppers. Wait, guys,
This is a whole bag.
You three start
And they're resealable.
and you three
Snazzy.
I don't know, we're gonna take
Okay.
colors and totals.
We're counting.
Get a paper towel to work on.
Wait, I don't think is it right now?
Oh, wait. Are we
missed the
separate?
worst day.
What are we counting for? The color of the number of the
Like a
colors.
percentage blue, percentage red.
So we need to count all of them.
So we count, let's just count the colors and then we can add
Okay,
them
wait,
up.
let's sort.
It'll be quicker that way.
Mars, real chocolate.
I think we're separating by color.
Yes, color.
Just count them and then count the colors.
Alright, we can turn off the
I think
video.
we count how many are
Grab
there.
that. We'll be back, Joel.
We're separating by color.
Do you want to do
Everybody's
Brown. Yellow.